Hello everyone, welcome back to Global Minima channel. Today we will be discussing pooling, one of the major components of a CNN. We know that a CNN consists of three major structural components: the convolution layers, the pooling layers, and the fully connected layers. Today we will be talking about pooling. Pooling is the operation of downsampling the input that is provided to a layer. And there are two different kinds of pooling: max pooling and average pooling. What does max pooling do? Max pooling identifies the most important feature in a particular region and neglects the other remaining information. To give an example, if you could see the figure that is mentioned here, in the orange region, there are four feature values: 12, 20, 8 and 12. But again, in that, we are only picking the most prominent feature, that is 20, and neglecting all the other remaining information. Similarly, we do for other non-overlapping regions as well, that is the yellow region, blue region and green region. And we end up downsampling the input by half. The 4 cross 4 input is converted to a 2 cross 2 input. Now let's discuss about the second type of pooling, that is average pooling. What does average pooling do? The task of average pooling is the same, to reduce the size of the input by 2. But how it does is, instead of taking the maximum feature that is present in a region, it takes the average of all the features that are present in a region. So if you consider the orange region that is present in the square, we know that there are four values that are present: 0, 0, 2 and 2. If we consider max pooling, we will be taking the maximum value, that is 2. But if we are considering max average pooling, what we will do is we will take the average of all these values. So 0 plus 0 plus 2 plus 2 by 4, we will be getting 1, right? Similarly, we can do for other regions as well, and we will be getting the values that are present on the right. So there is this debate whether max pooling is better or average pooling is better. But in general, you will see that people tend to use max pooling compared to average pooling. So we understood what is pooling and what are the different kinds of pooling. Now we need to understand why do we need pooling at all. The first reason why we need pooling is to reduce the input size. And why do we need to reduce the input size? Why can't we just keep on adding the convolution layers one by one? That is because if you only keep convolution layers, it would take a lot of time for you to reach a size where you can flatten it and keep a fully connected layer. And by that time, your neural network is so long that it would be huge and it would not fit on your computer's memory. So that is the reason you need to reduce the input size. And this can be done either by having pooling, or you can do a convolution with stride greater than 1. The second and important reason why we need pooling is to achieve local translation invariance. What does this mean? Let's try to understand it with the help of an example. We know that when we apply max pooling, we try to take the most important feature and take it forward. So in this orange region, what is the most important value? That is the highest value. It is 20, right? What max pooling is doing internally is, it is making sure that this highest value can be present in any of these four regions, and it doesn't make any difference. So this 20 can be present at this position or this position or this position or this position. It is not going to make any difference for max pooling because it is only going to take the highest value in that region. That way it is adding a local translation invariance. So these are the reasons for using pooling in a convolutional neural network. There is another variant of average pooling called as global average pooling, which we use generally towards the end of the neural network. What global average pooling does is, it takes the entire channel and finds out the average value of that channel instead of doing it only for a particular region. If we are doing it for a particular region, it is called as average pooling. If we are doing for the entire region, it is called as global average pooling. So in this example, you could see that there are three channels, each of size 4 cross 4. When we are passing it through global average pooling, we are getting three unique values. Every channel is reduced to one value, that is the average value. And why do we need global average pooling? We need global average pooling to replace fully connected neural networks that are present towards the end of the neural network. So why do we need to replace these fully connected neural networks that are present towards the end? There are two reasons. The first reason is to prevent overfitting. We know that when we add a fully connected neural network to the end of CNN, it adds a lot of parameters. And whenever there are a lot of parameters, it leads to overfitting. So that is one reason why we need to add global average pooling instead of having a fully connected neural network. Another reason is, having a fully connected neural network at the end makes the neural network fixed to a particular input shape. So I can't pass multiple input shapes. But instead of that one, if I have a global average pooling, irrespective of whatever size of input I pass, my neural network will be able to deal with that. So that is the reason we generally tend to prefer global average pooling instead of having a fully connected neural network at the end. I hope this video helped you to understand various concepts of pooling. For more such videos, like, share and subscribe to Global Minima channel. Thank you.